Okay, so for this one, let's go ahead and find out the third side of this one. So I'm going to do Pythagorean theorem. So 1 squared plus 2 squared equals c squared. And that's 1 plus 4, so 5 equals c squared. So c equals the square root of 5. So this side is square root of 5. So now I'm going to write out all 6 trig ratios and make sure they're in the proper form. So this will be sine of theta equals the ratio of opposite, which is 1 over square root of 5. I need to simplify that. Multiply by square root of 5 over square root of 5. And you get square root of 5 over 5. And cosine of theta equals 2 over square root of 5. Very similar. Multiply by square root of 5 over square root of 5. You get 2 square root of 5 over 5. And then tangent of theta is opposite over hypotenuse, or opposite over adjacent. There you go. Okay, the reciprocal functions. The reciprocal of sine is cosecant of theta equals. So that would be the reciprocal of this one. So it'd be square root of 5 over 1 or square root of 5. Secant is the reciprocal of cosine. So that'd be the reciprocal of 2 over that. So square root of 5 over 2. And then cotangent is the reciprocal of tangent. And that'd just be 2, because 1 over 2 flipped is that. So these special triangles. So these are all special. So let's see, this is going to be, to go backwards, this is going to be 5 divided by root 3. And we want to simplify that. So multiply by root 3 over root 3. You get 5 root 3 over 3. Multiply by 2, you get 10 root 3 divided by 3. 45, 45, 90. Oh, this is nice. To go backwards, divide by square root of 2, so you get 9, and you get 9. I mean, technically, if you want to write in the missing angles there, that's 60, that's 45. I think that's almost assumed in these problems. But solving the triangle means find all the missing sides and angles. So this one's 45, this one's 30, clearly. Okay, let's see. So this is 45. This is also 3 root 3. And this would be 3 root 3 times root 3, which would be 3 times 3, which is 9. And this one would be times root 3, so that'd be 12. And then times 2, so it'd be 8 root 3. Okay, well, I wish I'd left a little more room for this. I'm going to work kind of above this one, see if I have enough room to work it. Okay, so I'm going to try to draw a triangle here, given information. So A, B, C, so right away, it looks like, yeah, this will probably work, but let's just see. This is side, side, not included angle. You got to be careful. You got to do the test, right, when you have that case. So I'm going to start setting up law of sines and start solving. So sine of 42 over 15 equals sine of A over 19. So if you solve that, you get A equals the inverse sine of a big fraction here. It'd be 19 sine of 42 divided by 15. Okay, make sure it's degree mode. It is. So I'll just do the fraction first, just to see if you did the fraction first. It'd be 19 times sine of 42 over 15. If the number is bigger than 1 or smaller than -1, it won't have another triangle, but it is. It has at least one triangle, so I'm going to take the inverse sine of that to get the angle. So that missing angle here is 57 angle A is 57.9479 right there at that angle. Okay, so if I draw a second triangle, we'll call that A prime, B prime, C prime. Given information is the same, so 42, 15, and 19. But this new angle is the supplement of that. So what I'm going to do is 180 minus that angle is 122. So 122.7, 122.05. Let's see, I want more decimals. How's that? Press enter. 0.0521. 0.0521. So if I have those two angles there, 122 and 42, does that add up to less than 180? It does. Therefore, there are two triangles for this one. So there are definitely two triangles. Wow. All that work just to figure out there are two triangles. Okay, let's do number 7 here. So I was trying to work it up here. Okay, so I'm going to try to draw this. So the original triangle is P, Q, R. P is 3, Q is 10, and angle P is 42. So it does look like this is side, not included angle. I should do the test. I should set it up and start solving. So let's set it up. So sine 42 over 3 equals sine of, let's find angle Q there. So sine of Q divided by 10. Let's solve that for Q. So Q equals the inverse sine of a big fraction. That would be 10 times sine of 42 divided by 3. Let's throw that one in here. So first let's type that in. So 10 times sine of 42 divided by 3. Whoops. Sine of 42 divided by 3 is a number bigger than 1. Therefore, there's 0 triangles here because you can't, if you took the inverse sine of that, you're going to get undefined every time. Okay, so this one, I'm already suspect. Look at this. Like, one of them's 92 degrees, one of them's 89 degrees. It's already more than 180. I'm just going to say no triangle here. So I don't think we need to work that out. Let's try this one. So triangle ABC. So we get set it up because that is side. So sine equals sine solve that. Let's try that here. So we get 5, whoops, fraction bar 5 times sine of 101 divided by 8. It is a number smaller than that, so I'm going to take the inverse sine, smaller than 1. So inverse sine, oops. That number is 37. So that angle right there is 37.8422, 8442, 842. Okay, so I'm going to draw a second triangle. This is I'll take the supplement of that angle, so 180 minus that angle. Wow, 142. So I've got 142 plus 101. Oh my goodness, that's no triangle, right? So that second triangle is not a triangle, but the first triangle, we're good. That's less than 180, we're good. So there is one triangle in this one. So just when we tried to draw that second triangle, had a 101 and a 142, that's just way too much. It's way more than 180, so it's not going to work. So in this one, go in knowing that, one of these is going to be a two solution problem on the test. I don't know which one, might be this one, I don't know. This is the review, so but the test is going to have one, and it's going to count double, so it's going to count double for that one, just to keep that in mind. So let's kind of draw this one off to the side. So A, B, C. Angle A is 83. 18 is the side, and B is 32. So I've got to find this angle right there. So we're going to set up law of sines. So sine of 83 over 18 equals sine of B over 32. We're going to solve that for B. So B equals the inverse sine of a big fraction. So it'd be 32 times sine of 83 all over 18. Let's try that. So we get, first let's do the fraction, and then we'll do the inverse sine if we need to. 32 times sine of 83 all over 18. That's bigger than 1. So there's no triangle. Wow, that was easy. I was expecting a two solution problem, so it's nice when that kind of happens there. So let's try this one. So we're going to draw it. D, E, F. Now I'm really expecting a two solution problem, but we'll see. So D is 23. F is 88. And E is 78. Oh, now I'm not expecting a two solution problem because this is angle side angle. This is going to be a straightforward law of sines. It's going to have one solution. As long as those two don't add to more than 180, we're good here. So let's go ahead and find the third angle there. So just using your calculator, 23 plus 78, 180 minus that is 79. So this one's 79. Now we know quite a bit. Just going to do the law of sines twice, it looks like, and we should have this. Divided by lowercase e. So e is going to equal fraction so 88 times sine of 78 divided by sine 79. So little e is 87.6881. It's okay to just label it here. You could label it up there. Either way is fine. And then we're going to set up our law of sines again. So sine of 79 over 88 equals this. Solve for d this time. So sine of 23 over lowercase d. So d is the fraction 88 times sine of 23 divided by sine of 79. So 88 times sine of 23 over sine of 79. So we get lowercase d is 5.022. we've solved that triangle. Now we're finally so exciting here. So this is pretty much guaranteed to be a two-solution problem. So let's try it and see what happens here. A is 19, little b is 15, and capital B, the angle is 42. Okay, let's set up law of sines. Here we go. Sine 42 over 15 equals sine. We're gonna find this missing one right there. So sine of A over 19. We're solved that for A. So A equals the inverse sine of a big fraction. It's gonna be 19 times sine of 42 divided by 15. Okay, so A equals, I'm going to do this because I'm pretty sure this is going to be a two-solution problem. So I'm just banking on that. Let me go ahead and type it in. 19 times sine of 42 divided by 15. So far, 57, and we know it has at least one triangle, 57.9479. Okay, so we're going to draw a second triangle here. So A prime, P prime, C prime. Given information is the same, 42, 19, 15. But this first angle that we're solving for is going to be the supplement of that. So let's see. So this will be 180 minus that. 122. Let's get more digits here. 0.0521. 0.0521. Okay. So that definitely is, if you add up 122 plus 42, that's less than 180. So there are two triangles, and now it's just a matter of solving both sets of triangles. Okay, so let's do that. So let's solve for this angle here. So to do that, we're going to do 42 plus that 57 value, do 180 minus that. This one's going to be 80.0521. Okay, now we're just missing one side there, so let's solve that. So we get sine of 80.0521 over, I guess it's little c, equals sine of 42 divided by 15. So little c is equal to a big fraction here. So it'd be 15 times sine of 80.0521, all divided by sine of 42. Okay, let's type that in. So we get 15 times sine of 80.0521 divided by sine of 42. So we get little c is 22.0801. Okay, so we've solved the first triangle. Now it's just a matter of solving that second triangle here. So we've got a little bit of work to do. So let's add up the 42 plus the 122, if I can grab that one. 180 minus that is, so that's going to be 15.9479 for that angle. And then we just got to figure out the missing side, little c prime. There we go. So sine sine of 42. You could have chosen another angle. This one just seems easy to write. So little c prime is equal to, do the fraction here, so that'll be, I guess 15 times sine of 15.9479 divided by sine of 42. So 15 times sine of 15.9479 divided by sine of 42. So 6.1594. Okay, quite a problem there. Okay, now it's just using law of cosines. Okay, so there's two cases, and I don't know which case you consider tougher here. The big thing here, like on this one, the angle has to go in this spot, right? So we know in this case the angle is, our B is our C, so to speak. So in the formula, and our little b is opposite the big C, so we're going to do that. So it's in this form, it's going to be x squared, because that's the side opposite the angle there, and these two are opposite of each other here. So x squared equals, doesn't matter the other two sides, so what order? 20 squared plus 12 squared minus 2 times 20 times 12 times cosine of the angle, which in this case is angle B. No, it's 30. That's a joke. Okay, so cosine of 30, which is the angle. We know the angle. Oh, well, this is, it's pretty straightforward here. So you just, type that in. So 20 squared plus 12 squared minus 2 times 20 times 12 times cosine of 30. Seems a little long for that last side. That's because x squared is equal to 128.308-ish. Not going to get the decimal because I'm about to square root of that number. So we got to square root that to get the answer. So I'm just going to grab that. So we get x equals to 11 point, equals there, 3273. In this case, we only really have to find the missing side or angle. So in that case, we're kind of done. This one, we have to find the angle here. So the side opposite that one is 20. So we plug in D is our, that's going to be D now. That's going to be our lowercase d over here. So it's going to be 20 squared equals 10 squared plus 12 squared minus 2 times 10 times 12 times cosine of capital D. Okay, so now we've got to solve this. Could do what I can here. Simplify it. 400 equals, let's see, what is that? 10 squared plus 12 squared. You might know that without a calculator, which is great. What is 2 times 10 times 12? I guess I've got 244. 244 minus 240 times the cosine of C, or D, there. Okay, remember, you cannot just subtract those two. 240 is being multiplied by the cosine, so you have to subtract 244. You always subtract first. So subtract 244. Get 156 equals negative 240 times cosine of capital D. Divide by negative 240. So in your calculator, you're going to do 156 divided by negative 240. So cosine of D equals negative 0.65. Should we take the inverse cosine of both sides of negative 0.65, and you get d equals 130 point, just get more digits here, 5416. And you've got it. Okay, we're almost there. Wow, only 15 problems. Ooh, that means each one's worth kind of a lot on the test. Okay, so be aware of that. You want to get each one of these. So from a point A of the ground, well, it's got it pretty much drawn there. Find the height of the building. So we're looking for this distance here, x. So I think we could use, and right away I see we can figure out this angle, right? So let's do that. So it's be 180 minus 30.2 is 149.8. That might help us. I don't know. I see that there are two triangles there, at least. I really maybe, let's try to find, it'd be nice to be able to find y. I don't know if we can, but that would be ideal if we could find y there. Oh, we know the other. If we know two angles, we know the third angle there. So let's do that. So get 24.1 plus 149.8, 180 minus that. So the head angle up there is 6.1 degrees. Okay, we're getting somewhere. Okay, so now we could set up law of sines and figure out y. And once we know y, we could probably set up and figure out x there. So let's try that. So let's use law of sines to figure out y. 6.1 over its opposite side, which is 600, equals sine of 24 over its opposite side, which is y. So y is going to equal a big fraction here, 600 times sine 24.1 divided by sine 6.1. 600 times sine 24.1 all divided by sine 6.1. Wow, this is pretty long. Okay, so I guess that could be. So y equals, yeah, it's a pretty small angle there. Y equals 2305. I don't think I drew the thing to scale. Let's just double check that looks about right. Okay, so it is more. So 0.5608. 608. Okay, so now we know why. I mean, you could just use sine at this point, right? So that's a right triangle. Just the way they describe the question, it's got to be a right triangle, so it's straight up height. So sine of 30.2 should equal the ratio of x divided by y, which is 2305.5608. So x is going to equal 2305.5608 times sine of 30.2. Okay, we're going to multiply that by sine of 30.2. We get x equals 1159.7. Let's just see more digits here. 7431. 7431. I think that's what it's asking for, right? Find the height of the building. Okay, I think that's it. Thanks.